Welcome back, lesson 3.1, video 3. So in this one, we're going to talk about vertical stretching and shrinking. So let's get straight to that. Vertical stretching and shrinking happens if C is multiplied to the function. Then your graph is going to undergo either a vertical stretch or a vertical compression or shrink. So basically, it's very straightforward. It's very common sense. If you multiply by a C value that is between 0 and 1, which means it's a fraction, it's a small number, then you get a vertical shrinking. The fractional value pushes those Y values down. Whereas if your C is larger than 1, if you get a bigger number, then you get vertical stretching. That C value multiplies it and pulls the Y values up. A good way to keep this straight is to think about a rubber band. So if you think about a rubber band, I've got my little hair scrunchie here. If I do a vertical stretch, then it's going to get taller, which means it's going to look like this thing is getting skinnier and taller. If I do a vertical shrink, it's going to push it down and it's going to get short and fat. So when you're looking at your graph, expect when you multiply by something for it to look skinny and tall. Expect it to get short if you multiply by a fraction, by a value that's between 0 and 1. So let's go ahead and do a couple of examples. First thing it says is describe the transformation that would happen to the graph of x squared if it was multiplied by a factor of 4. It would be a vertical stretch, because this is a value that's larger than 1, a vertical stretch of 4. Sorry about the bad handwriting. But here's what that would look like. Each of these points would get multiplied by 4. So instead of 0, 0, 0, 0 would actually stay the same. I'm going to actually do a little T-chart and show you what this would look like. So the original values, if I had an x value of -1, 0, and 1, this original function has -1 squared, which gives us 1. So that's how we got that ordered pair -1, 1. And then 0 squared is 0, which is where that ordered pair came from. And then 1 squared is 1. So that's where this ordered pair 1, 1 came from. If I do a vertical stretch on this, then each time I'm going to multiply it by 4 after I square it, because I am going to follow my order of operations. What I'm going to do here is I'm going to write down exactly what this is going to look like. I'm going to have 4 times -1 squared, and then 4 times 0 squared. I'm just plugging that in for my x, and then 4 times 1 squared. Well, -1 squared is 1, so 4 times 1 is 4. So I have a point at -1, 4. My x value is -1, my y value is 4. 0 squared is 0, and 4 times 0 is 0. So I'm going to stay at the origin for that ordered pair. And then here, 1 squared is 1, times 4 is 4. So 1, 4 is that ordered pair. So what I end up with is a tall, skinny parabola. Just like we expected. That was a vertical stretch. Again, think about my hair bow. I stretched it, it got tall and skinny. All right, this one, it wants us to write an equation that would vertically shrink it by a factor of 3. By a factor of 1/2. So my function is 3 to the x. I want to vertically shrink it by a factor of 1/2. So that is going to be, let's say h of x equals 1/2 times 3 to the x. And I'm going to do that one in Desmos so you can see it. I've got, let's get that out of the way, and do 3 to the x is my initial function. If I want to do a vertical shrink, it's hard to see on exponentials, but what you're going to have is 1/2 times 3 raised to the x power. and it just gets a little bit shorter here. This was at 1. This ordered pair was 0, 1. Now this ordered pair is 0, 1/2 or 0.5. Okay, so that's what your vertical stretches and shrinks are going to look like. You guys go ahead and try a couple. Graph them to help you see it if you want to, especially on Desmos, but you can just write the equations. Don't forget to check your answers, and I'll see you on the last video.